All right, so welcome to this week's lab, and it is going to be the milk experiment. This is something that you can do at home if you would like, if you have some cold milk, some food coloring, and some soap, and a shallow dish. This is kind of a cool thing you can do. Or we are going to do this lab for you this week. And remember, the things that we are learning about are the standard apparatus, the Bunsen burner, and then different variables. So we're going to try to work this in as we go along with this lab. This worksheet is posted underneath this lab, but you do not have to print it if you don't want. But do remember, there will be 1 or 2 questions on tomorrow's or Friday's quiz over what we're doing here today.
Yep.
All right.
Milk lab.
So first, we're going to start off. We have a couple different samples of milk. Mr. Pilcher, what kind of milk do you have?
Well, you can clearly see labeled in front of me that it is skim milk.
I have 2% milk.
And what I have here must be whole milk.
You have whole milk. And so what we're going to do, we are going to do this experiment twice. We're going to do it once with cold of our varieties of milk, and we're going to do it another time with hot. So in order to do that, we need to heat the hot milk, and we're going to set up a standard apparatus, and we are going to heat our milk.
It's going to be movie.
Oh my God.
Movie.
All right.
Mr. Pilcher, how do we put together our standard apparatus?
I'm glad you asked, Billy. Let me show you. First off, we're going to start with that base of the ring stand. We'll plop it down there. Secondly, we have the pole that goes into the ring stand. There's a little hole in the ring stand that you can just screw this into, like so. These things are all covered in rust because they're 4,000 years old. Next, I like to take the Bunsen burner and plop it right there on the base of my stand, and that's going to let me know how high my small ring clamp needs to be. I'm going to take my small ring clamp. I'm going to slide it down there. I'm going to put 3 fingers on top of my Bunsen burner, and that lets me know exactly how high this small ring clamp needs to be. I'm going to tighten that there. After the small ring clamp, we're going to place our wire gauze used for even heating. After that, we're taking our large ring clamp. We're going to lower that down on there. Lastly, I'm going to take my beaker for my skim milk. I'm going to plop it onto my small ring stand, or my small ring clamp rather. And I want the large ring clamp to be going up about halfway through that beaker. That way it provides support and the beaker can't really go anywhere.
Mr. Pilcher, how do you take a hot beaker off of your standard apparatus once you're done?
Oh, I hadn't thought about that. Oh, wait. Yes, I did. With beaker tongs that aren't stuck to the utility clamp. It will be like this. Look at this, children. Look at this. Look at that wrist action. There we go.
Now that we have our apparatus set up, now we have to light our Bunsen burner. But there's still one thing we got to do before we light our Bunsen burner, kids. 2 things, actually. First one is goggles. What's the second thing, Ms. Bay?
We always have our hair back and our goggles on whenever Bunsen burners are lit in our classroom.
Yes, we do.
Awesome. Now we're ready to get our Bunsen burner lit. Make sure you reach over, turn on the valve at the base of your station. Take your handy dandy spark igniter. And we can light our Bunsen burner. See how Ms. Bay is the A student. Ms. Pilcher a little slower there.
Slow and steady wins the race, nerds.
So now we have our Bunsen burners lit. What kind of flame do we have here, Johnny?
Well, it looks orange to me, so I'm going to go with birthday candle.
Do you agree, Jane?
I do agree. And I know to make it not a birthday candle flame, we want to add oxygen.
All right. To add oxygen, hope you guys remember, you're going to grab that barrel at the top of your Bunsen burner, and we're going to turn it counterclockwise. All right, we want to open it up a little bit, get a little bit of oxygen in there. Now notice how once the flame goes away, the yellow, now we have a blue flame, probably really hard to see.
Yes.
Yeah, now we have a nice, pretty flame. It's no longer our birthday candle flame. What kind of flame do we call this, Jane?
Big blue.
Big blue. That hurts me as an Ohio State person to say that. All right, so we need to do something more. How about it? How about it, Johnny? What do we got to do?
Well, I think we got to find that perfect 1-to-2 ratio of methane gas to oxygen gas.
All right. So we're going to keep opening our oxygen a little bit more.
Hey, I got the perfect flame first before everyone else. Crazy.
Yeah, then you'll get that nice perfect flame. That outer blue flame is a little bit darker in color, but it's dim.
Mr. Pilcher has really big fingers, so his is too big.
Yeah, his is too big. And you get that inner blue flame to be that nice 3 fingers tall.
Oh, yeah.
Awesome. Now we're ready to put our Bunsen burner into our standard apparatus.
For like 2 seconds.
Remember, when we're putting our beaker on, use your beaker tongs.
Oh, I already have my beaker on there.
Cold, cold, cold. And hot.
Yep.
And we're going to put our beaker on with our nice beaker tongs. We want to make sure that that flame that's right about the bottom of our beaker. And now we boil.
Looks like someone threw up some Skittles.
All right. So what we're going to do next is we're going to do the first experiment for you guys to gather some visual data on. So we're going to start in the basic procedure, and it says pour milk into the Petri dish so it's approximately half full.
Don't spill.
Okay. Then we're going to place a drop of food coloring of each of the colors in around kind of like the clock. So like at 12, 3, 6, and 9.
Nice phrasing there.
Thank you.
How many drops should we put in?
1 drop.
Now, be careful, kids. Remember, you want to keep your blue dot and your yellow dot separated from each other. You don't like blue and yellow
I didn't
next to
understand
each other.
where you were going with that. All right, and next we're going to take a little bit of dish detergent. We're going to pour it into a weighing boat so we can easily scoop some up here.
What you got there? You got
Dawn.
some Dawn?
Yeah.
You get a little Ajax.
Ajax.
Yeah.
Woo.
It's orange. Great
All right.
color.
And then what we're going to do, and we'll zoom in for this, is we are going to get a little bit of the soap, and we're going to place it right in the center of our Petri dish. I want you guys to pay attention to kind of what happens, how the colors move. So we're going to grab some soap, and we are going to place it in the middle of the Petri dish. 1, 2, 3, go. Nice. I'm going to put some, oh, look, yours is just going.
Oh, beautiful.
Put a drop over there, maybe. A little drop over here.
You get a big glob there. Oh, yeah. I wasn't second team All-State in coloring my junior year for nothing.
Good stuff. Oh, yours is going nicely.
Yeah.
I got a deep milk dish.
Yeah, I guess less is more.
Less is more.
All right, Dr. Yates, what type of milk did you have?
I had the whole milk. This was the hot whole milk, cold whole milk.
Yep. And then that's 2%. Is yours still moving over there, Mr. Pilcher?
Yeah,
Skip.
a little bit.
All right. Now let's do this exact same thing, but let's do it with warm milk instead. All right. Now we have our warm milk, and we're going to do the exact same process. We are going to fill our Petri dish up halfway.
Needs my bigger tongue to pour.
And our 4 drops of food coloring. All right, so we're going to do this again, thinking about what it looked like before, and now we're doing it with the same type of milk per person, but we're going to use hot milk instead. Ready?
All right, here we go.
1, 2, 3, go.
Oh, yeah.
Woo, buddy.
Beautiful.
Whoosh.
Nice.
It's like a pinwheel. Oh, it's still going.
There it is.
Oh, that's nice to look at.
Yeah, that's really pretty.
Oh, mine's freaking out.
Freaking out, huh?
It is. I only put the original blob in there.
Yeah, it's just still
I'm going
going.
to plop a blob up here. Boom.
Yeah.
Whoa, man. Far out, brother. Yeah.
All right, so let's give it a little zoom here.
Looks like your lab coat, Mr. Pilcher.
It does. All right, Dr. Gates, again, you were whole milk,
Whole milk.
2%,
Skim.
and skim. They all still seem to be going. All right, so now we're going to do our post-lab questions.
Mm-hmm. Hey, how many milliliters of milk did you guys use?
I don't know.
All right, just a little bit.
Are toothpicks different? I use a small toothpick.
I got a huge toothpick.
I got a tiny, tiny toothpick.
Oh, but you guys, how fast were your colors moving? You know
Fast.
They went,
how many seconds is fast?
I don't know.
I don't know either.
I have Dawn dish detergent.
Is that the same as Ajax?
No.
Oh,
But
We
that's
used to-
tropical lime.
Oh yeah.
well, I got orange though. Oh, and you guys always put a second drop at the top, right, of soap?
No.
I did.
I put mine in the middle.
How many centimeters from the edge did you do it?
3.256.
You are a liar.
All right. I think
Now that we've finished our milk lab, let's talk about some of the things we were hoping you would get out of this experiment today. And that's what we put into our post-lab questions on our labs. So the first thing we want to talk about here is how many variables, what were the possible variables in this experiment? Well, here I want to focus on the ones that we controlled and what were the ones that we varied, right? So if it's a variable, it's something we varied. So there are really two variables that we varied and controlled in this experiment. First was the type of milk. Remember, we had the skim milk, the 2%, the whole milk. And we also changed the temperature of the milk. We had some milk that was room temperature, and we had some milk that we'd heated up on our Bunsen burners. We had it so it was hot milk. Okay. There are probably plenty of other variables that were in here, some of them that were in our control, some of them that were not in our control. But those are the two I want to focus on for the ones that we controlled. And if they're ones we controlled, what do we call those variables? What type of variables are those? Well, hopefully you said independent variables. That's what we're looking at here. Now, there were some other variables that were kept constant for this experiment. What do you think those were? So if you think back to what we did in this experiment, what did we not change as we did our experiment? Well, the first part is we didn't change the milk. We had the same milk that we used for the hot milk and the cold milk. We had the same process, right? We followed the same process that we did for the cold milk that we did for the hot milk. We also used the same soap throughout the experiment, right? And the same toothpick or little piece of wood to put the drops of soap in. We used the same food coloring for the different parts of the experiment. So lots of things were kept constant. We try to keep as many things constant as we can. Which variables changed? So here are probably the variables that we controlled: the type of milk, the temperature of the milk. But there are a whole bunch of other variables that we did change, right? How much milk did we use? Right? That we might not have done that the same from the hot milk to the cold milk, or even between the three of us. How about the volume of the soap? Well, we were doing it off of little toothpicks, if you remember, so that's really hard to get an exact measure of how much soap we used. We definitely changed the type of soap, right? All three of us were using different soaps. At least Mr. Pilcher and I were using the same brand, but we were using different types of their soap. The actual temperature of the milk, there was different temperatures of the milk between the three of us. The amount of food coloring, oh my Lord, we did our experiment twice. right? Did we use the same amount of food coloring each time? Was it exactly one drop? And how exact are each drop? Are they the same time to time? So we could have easily changed the amount of food coloring. And the concentration of the food coloring, right? So did we have the same amount of milk? And if we didn't have the same amount of milk, then we changed how, and we put the same amount of food coloring in, we'd have a different concentration of food coloring. So there's a whole bunch of variables that are changed in there. We could have had some other things that could have changed in the room. How about the wind or the way the air was moving around the room as we did this experiment? It might have changed a little bit from one run to another. There's so many other things out there. Some of them we can control, some of them we can't. And finally, I want you to think about this. Was this a scientifically good experiment? I want you to think a moment for why or why not. So remember, if you want to be a scientifically good experiment, this is an experiment that we are able to take one variable, maybe two, and we're able to control how the values of those variables. So it's very, very orderly, very methodic. And we would test one variable, we change it, we test it again, we change a variable, we test it again. So we try to keep everything constant except for the one variable that we're changing. Right? Did we really do that in this experiment? Was everything the same between our trials? Well, not even close. Right? We talked a little bit about some of the variables on the last slide. Did we use the same amount of milk? Did we use the same amount of food coloring? Did we use the same amount of soap? Right? Those were three very good things that could have differed between our cold milk trial and our hot milk trial, right? Lots of different potentials there. All right, so again, what I want you to think about here is we're types of experiments. Remember, think about our independent variables, our dependent variables. In this case, what was our dependent variable? Right? Our dependent variable was the how did the food coloring move around in our petri dish of the milk? Right? How did that move around? Did we measure it? How did we measure it? Well, we didn't have a timer. We didn't have a way to measure the distance that each one of these went through. So this was really kind of just a very simple observation without a lot of detail. If we wanted to make it a little bit more scientific, we would have measured a lot more than just simply, look what happened. Right? How long did it take to start mixing? Where did the food coloring drops go? Again, how fast, how far? How did they mix? Did they keep separated? There's so many things we did not monitor or really measure that prevented this from really being a good experiment. All right, guys, that's it for right now. Thanks a lot. Hope you had fun with our milk lab today.
Coconut butter. All right.
Are we filming?
We're just going to start.
Look less enthusiastic.
Flip that around.
Wait, is my head cut
Okay.
off? You can't see the tip of the peak of my head.
Gosh.
You're gonna have
He's upset because his head is cut off.
I'm
Just
sorry.
tip it up. Just tip it
Why
up
don't
a
I just
little
cut half
bit.
of your head off and see how you feel about it?
I wouldn't even see over it.
I'm
All
actually
right.
like 5'1" in real life. It's like movie stars are always shorter than you think.
Oh, yeah.
He's just standing on a box the whole time. All right.
Oh man, I just thought of it too, and I was like, I'm gonna throw that one in there.
All right. So
Moving. It's gonna be utterly amazing. There's so many cow puns.
all right. So
That's not true.
would you get away from the camera? Let's go.
You put your star closest to the camera. I don't know what you want.
Oh my gosh! Start telling us what to do. Start. Start.
What we gotta do, Mr. Bilson?
Miss Bay's 1% mad at me. You guys get it? No.
I don't even understand.
I'm filling up the blooper reel. That's what I'm doing. 1%, 2%. No.
That was terrible. Like that was really bad. Apparatus. Go.
Mr. Pilcher, how do we set up our standard apparatus?
I'm glad you asked, Billy. When you're recording live, the stakes are always too high.
I thought it was milk.
Yeah, but milk is from cows. Steak is from
You were
cows.
stretching.
Oh, I thought this was the steak you were talking about.
That's worse than my joke.
All right.
We're hoping during this lab we can really get some vitamin A. Wait, what's in milk again? Is it vitamin C?
It's vitamin D.
Vitamin D? Oh, I don't want to include that. Oh my god! Oh, we can't include that in the bloopers.
So what kind of flame do we call this, Mr. Pilcher?
Well, it's orange, so I'm gonna go with big blue.
What?
I thought you said you were going to remedy it. Oh,
You're
you're right.
remedy it. What do you mean?
I thought you meant you were going to correct me that time.
No.
Okay. All right. One more time. Oh, working with amateurs.
Oh,
all right.
my God.
Okay. All right. We're fine.
All right, guys. Hopefully you had fun watching that video. We had a lot of fun making the video about the Milk Lab. But now, as we finish today, please don't forget, take the participation points quiz. And remember, there's one question. How did you earn your participation points this week? Make sure you click only one, choose one of the answers, A, B, or C. A being that you attended the Wednesday live class, B being that you came to office hours today on Thursday, or C, that you made arrangements with me outside of those 2 times to discuss how you're doing with chemistry this week. Thanks a lot, guys. Good luck on the quiz tomorrow.